we tend to have a very educated workforce.
Work each day in a safe manner and leave the environment intact for the next generations coming up.
Indian people feel that they are connected to the earth.
We also have the ability to produce our own power.
Petroleum products like natural gas and car gasoline are designer products. They are processed to exact standards that allow them to burn cleanly in your home or in your car. Between the wellhead and the consumer are the processing facilities, refineries, and the factories, which, through a number of steps, turn raw petroleum into safe and usable products. Petroleum reservoirs are created over millions of years by complex processes under extreme conditions of temperature, pressure, and chemical reactions. These reactions produce unique mixtures of hydrocarbons and other substances. These hydrocarbons can be gas, liquid, or a near solid. Crude oil and natural gas production requires processing to remove undesirable contaminants before the final product goes to market. How you process or refine the petroleum depends on what end products you're after. Processing facilities separate raw petroleum into a variety of products. Crude oil, a mixture of liquid hydrocarbons. Sales gas, composed mainly of methane, the simplest hydrocarbon molecule. Natural gas liquids, or NGLs, which include ethane, propane, and butane. Condensate, a gasoline-like liquid byproduct of natural gas processing. And sulfur, which is converted to liquid or pellet form for shipment by pipeline, truck, or rail car. Processing uses well-established techniques and equipment common to all oil and gas operations around the world. Thousands of Canadians are employed in these processing facilities and plants. In fact, Canadians are considered international industry leaders in these areas. The processing facilities are located as close as possible to the production sites. In doing so, they generate considerable economic benefits to rural areas. Many of the petroleum wells in this province produce only raw gas, which is processed into natural gas, consisting almost entirely of methane. In gas reservoirs, methane is found in mixtures with heavier hydrocarbons like ethane, propane, butane, and pentanes. Water vapor and other gases like hydrogen sulfide, carbon dioxide, and nitrogen may also be present in varied amounts.
The driving mechanism to get the gas from the formation into the plant is just pressure differential. In this case, there's pressure that's contained within the reservoir. The reservoir is about 3,000 meters below the surface of the ground that forces the gas up to the wellhead. At the plant, the gas is compressed in a compressor in order to get it up to the plant, or the pressure at which the plant can process the gas at.
There's two types of compression. You can have compressors out in the field sites to push the gas into the plant, or you can have the compressors in the plant to actually suck the gas into the plant. So it's the difference in pressures that allows the gas to flow through the pipeline. When it gets to the plant, then it'll go through the inlet separation to remove the water and the hydrocarbon as a liquid. Then we'll go through a dehydration tower to remove the last bit of water. And then we'll also go on to a refrigeration system to cool the gas to remove the LPGs and light hydrocarbons.
Gas processing facilities are considered a part of the midstream end of the industry.
The main essential difference between a sweet gas and a sour gas plant is that a sour gas plant is designed to remove hydrogen sulfide, or H2S, from the inlet gas. Sweet gas primarily is methane, whereas the sour gas has methane and some quantities of H2S in it. Wet and dry, when you're talking about a gas, can refer to either the hydrogen carbon content or the water vapor content. Almost always when you produce gas from a reservoir, it is saturated with water vapor. And of course, water vapor will cause the gas to freeze in pipelines, and so we remove that so that gas can be transported without any problems. We call it sulfur, but really what we're removing is H2S from the methane gas. And that is done in the presence of a liquid solvent. And in one of the towers that we see over there, we have gas flowing up the tower and a liquid solvent that flows down through the tower. And as the solvent and the gas mix, H2S is absorbed by the liquid solvent, and the methane is allowed to go off the top of the tower free of any carbon dioxide or hydrogen sulfide. The hydrogen sulfide is then taken to another tower that you see behind us, and where the solvent is heated, the H2S is released from the solvent, and that H2S is then taken to our sulfur plant where we turn it into elemental sulfur. The sulfur process we use at Crossfield is called a three-stage Klaus process, and that simply means that we have three converter beds. The converter beds contain the catalysts that speed up the reaction between sulfur dioxide and hydrogen sulfide to form elemental sulfur. And the three stages are those three converters that you see. They're large diameter vessels that are about 12-foot diameter and 85 feet long. Each one of them contains 100 tons of catalyst. Now the catalyst is a chemical that looks like a bead, and it speeds up the process of H2S and SO2 forming the sulfur. Okay, we're currently standing in the center of our process building. This is a part of the plant where we remove H2S and CO2 from the sour gas, and then further treat the sweet gas by dehydrating it, by removing both the hydrocarbon and the water vapor so that it is a saleable product and it meets our sales gas specifications.
This particular gas processing plant would process about 400 million cubic feet of gas a day, and that would be enough to heat 400,000 homes for one day.
Hydrogen sulfide is a highly poisonous gas. Compounds of sulfur and oxygen, mainly sulfur dioxide, are also an environmental concern. Gas processing accounts for 44% of Alberta's sulfur dioxide emissions, and that in turn is about 15% of Canada's total emissions. The environmental and engineering standards that govern gas plants in Alberta are some of the most stringent in the world. At Alberta's sour gas facilities, hydrogen sulfide recovery is in the range of 99%. The basic process for dividing the gas stream into methane, ethane, propane, and butane is called fractional distillation.
The process of the fractional distillation starts at the bottom of the distillation tower in the kettle. After the feed is loaded into the kettle, we start by heating up the bottom. As the kettle is heated up, the vapor phase starts going up through the column. Throughout the column, we're going to have mixtures of different boiling ranges, where the top of the column will be a lighter boiling range and the bottom will be a heavier boiling range. As the vapors go up through the column, they go to the very top, and that's where we have our condenser. And as they hit the condenser, which is at a lower temperature, they condense into a liquid. And as they condense into a liquid, they flow into the collection flask. That is where we collect the component of interest. So during a fractional distillation, you can isolate a certain range of your feed material depending on the boiling point you're looking for. So basically you can separate really fine boiling range mixtures.
Each of the petroleum fractions has a different boiling point. Capturing this gas and storing it in a separate container is the way each of the natural gas liquids is harvested. The gas emerging from most plants meets pipeline specifications for dry gas, but still may contain small quantities of gas liquids which are removed at straddle plants.
The pipeline is going past us, we're just straddling it, and the gas is actually going through us and then back onto the pipeline and down again. We're probably the biggest expander facility in North America. We're sitting on 6 lines that go past us. They're a gathering system from all of Alberta. This gas gets piped into these 6 lines, and then it heads all the way down past Montreal, around to Toronto, and even into the States. The gas goes through our facility and then back out and down to TransCanada. While it's in our facility, we take out some of the NGLs.
There's about 9 billion cubic feet a day of gas that goes by. We process about 5 billion or 140 million cubic meters a day of gas.
We bring the gas in, and when the gas comes in, it's got a certain percentage of propane pluses, a certain percentage of ethane, and we will take the gas, drop it through our expander, which drops the pressure of the gas, and thus cooling the gas. And by cooling the gas, the liquids drop out.
These are called turbo expander plants. The reason for that is we drop the pressure. When you drop the pressure, the gas gets colder. But with a turbo expander, you have one wheel that you're dropping the pressure again, and that, through a direct shaft, drives a compressor. And when you're doing work, work is heat, and you're taking heat away. So therefore, we're able to get down to minus 100 degrees C going through a turbo expander, whereas if we just dropped it across a valve, we'd only get down to about minus 70 degrees C.
150 megawatts will burn on any given day. If we would shut the plant down, everybody go on holidays for a month, we would still get a $2 million power bill. The markets for the ethane are in Joffre, and they take the polyethylene out of there, and that's where your plastics come from.
In the petrochemical industry, naturally occurring petroleum molecules are changed into molecules that are useful in the creation of a wide array of modern consumer products. Many things Canadians use in their everyday lives are made of petrochemical molecules, which initially came from petroleum. Petrochemical plants create intermediate products, the building blocks for many consumer goods.
On our site here at Joffre, we bring in ethane as a feedstock. Ethane is a component of natural gas that is removed at other plants in the province and collected in a gathering system and brought to our facility.
Here we crack the ethane and make it into ethylene. So what happens is we've got the ethane coming in through a pipeline, comes into the plant. The furnaces are hot enough that it'll break down the chemicals and make it into ethylene. So form the single bond into a double bond. And while they do that, they make a whole bunch of other co-products as well. So they heat it up, and then it goes through a series of separations. So we get out the ethylene, and then we get out different products that we can also sell.
The co-products are hydrogen, which we sell to a company just down the road from us who use it to produce ammonia. The other co-products would be C3 kind of products, propylene, propadiene, C4 kinds of products, butanes, butadienes. Those are used in the rubber industry. And a C5 plus product, we call it, is sort of like a gasoline product, and we sell that into the gasoline pool. The ethylene that we make, which is our primary product on site, we sell to ourselves to make polyethylene.
The vast majority of our polyethylene product is used to make polyethylene resins and wraps. Some of it is upgraded into hard polyethylene plastic toys, margarine container lids, that type of product.
We will be selling it to Amoco, who will be using it to produce linear alpha olefins, again on this site. Some of our other customers use it for production of ethylene, oxide ethylene glycols, other polyethylene plants and other products like that.
One of our most important goals here is to minimize the impacts that our products have on human health and the environment.
Really, responsible care is doing the right thing, and that protects all of us, the workers here in the workplace, their families, and their communities today and into the future.
In Joffre, we take our goals related to responsible care very, very seriously, and we work very hard to ensure that Joffre is a safe place to work for everyone.
Crude oil is not processed in the same way as natural gas and natural gas liquids. The main consumer product derived from light crude oil is gasoline. However, there are a number of other products that come from light crude: NGLs, kerosene, diesel fuel, lubricating oil, and residuum. The transformation of oil into gasoline happens at an oil refinery. Where gas processing occurs at the midstream end of the industry, oil refining takes place downstream. Most of Alberta's crude oil production leaves the province by pipeline. The Enbridge pipelines carry Alberta oil east to Ontario, where it is refined, mostly in Sarnia. The Rangeland pipeline moves oil south to refineries in the United States. Trans Mountain pipeline moves Alberta crude oil west to British Columbia. Like natural gas and natural gas liquids, crude oil is a mixture of many different kinds of hydrocarbon molecules. If crude oil were to be distilled into its fractions the way field gas is distilled, only 1/4 of the whole would be left usable as car gasoline or diesel fuel. The problem of how to get more gasoline and diesel fuel out of crude oil has been occupying the refining industry ever since the early 20th century, ever since the advent of the automobile. In 1914, Imperial Oil began using heat to crack large hydrocarbon molecules into smaller gasoline-size molecules. Since then, many processes have been invented to increase the amount of gasoline realized from a barrel of crude oil. They either add hydrogen or subtract carbon from carbon-rich hydrocarbons. Adding hydrogen is called hydrotreating. Subtracting carbon is called coking. Though gasoline and diesel fuel are the main products of oil refineries, other products are produced as well. Refineries change the balance of their products according to season and demand. Oil refineries in Alberta must meet stringent emission regulations that govern gas processing plants. Refineries in Canada were originally designed to process light and medium crude oils. However, increasing production of heavy oil and bitumen in this country has created serious challenges to the refining industry. A high proportion of Alberta's remaining petroleum exists in these forms, so it's a challenge we have to meet. Because bitumen exists as an oil or tar sand, the first step in refining it is to separate bitumen from the water and sand.
If oil sands deposits are near the surface, then you can remove them by surface mining, which is basically digging the oil sands out of the ground. But if the oil is really deep down in the ground, then it's not possible to dig the oil sands out of there. So you have to use other methods to remove the soil. One of the ways to remove that oil that's deep in the ground is to use steam. This steam is injected into the formation and it condenses and gets into this porous rock and allows the oil to become fluid, and therefore we are able to pump this fluid out of the formation using downhole pumps and pump jacks.
We have between 8 and 10 wells on a pad. The reason they're located on what we call a pad is to cut our structure costs down. The wells are horizontal wells. They go down about 450 to 475 meters, and then they extend out to a total length of 1,500 meters into the pay zone. We've got 329 production wells at this particular facility, and they're all horizontal.
The fluids that come to the surface include the bitumen oil and as well as gas and water, as well as some impurities like solids, clay, and silica, calcium, and magnesium come back with the water. And so these are all the impurities that we have to remove before we can ship our product. We dilute our oil with condensate or light hydrocarbons, which reduce the viscosity so that the shippers can handle this oil at ambient temperature. At ambient temperature, our oil is so thick that it won't pour, and you can't pump the oil with regular pumps. So we have to reduce this viscosity so that they can pump our product to the refineries.
Basically what you have down there, if you ever saw a core sample, it's almost like play sand full of tar, and it's got little streaks of clay in it. The less clay the better, because your steam can penetrate through the sand and make the oil more viscous so that it'll flow easily to the wellbore and we can bring it up to surface. But if you just took a sandbox and poured a bunch of heavy oil or a bunch of oil on it and clumped it up, that's what the reservoir would look like.
Though petroleum products do travel by truck and train, the greatest volume of petroleum moves to consumers by pipeline. There are more than 280,000 kilometers of pipeline in Canada, and the number is growing every day. Pipelines differ according to what they carry. They fall into 4 general categories: gathering lines, which move raw petroleum from wellheads to processing plants and transmission facilities; trunk lines, that transport crude oil and natural gas liquids to refineries and petrochemical plants; gas transmission systems, that move natural gas at high pressure from producing areas to consuming areas; and local distribution companies, delivering gas at low pressure to homes and businesses. Crude oil, gas liquids, and refined products are also transported by tanker, barge, railway, and truck. Elsewhere in the world, specially designed tankers carry liquefied natural gas, or LNG, across oceans. LNG is supercooled methane. Regulators set strict environmental standards for pipeline construction and operation. Crude oil moves from source to refinery more slowly. Again, compressors are required to supply the force that moves the oil at a speed of about 8 kilometers an hour. It takes as much as a month for oil to travel from Alberta to Quebec. The incredible web of wells, pipelines, plants, and refineries that connect petroleum in reservoir rocks to products which fuel jets, to producing plastic consumer goods, is almost impossible for the mind to comprehend. It is so vast, complex, and interdependent, and yet it works. As we move into a new millennium, petroleum remains the most widely used fuel on Earth. Whatever the future might be, petroleum is the fuel that will bridge our future.